Hi everybody. This video is about writing algorithm for linear pattern search. Let us see how to develop the logic and write the algorithm for linear pattern search. Let us understand the problem first. Design a pattern searching algorithm that is linearly dependent on the length of the text being searched. You need to find out how many times the pattern occurs in the text. That should be displayed as your output. Say for example, this is your search pattern and this is your text. Now I need to identify how many times this particular pattern is appearing in the text. So by manual observation we can see that this particular pattern appears here in this particular in this position, and in similarly the same pattern appears here also. So the number of match we found in this text is 2. So this should be your output. Now how do we proceed with this problem? So in a general algorithm, what we do is, we'll take the text, we take the pattern, compare the first corresponding characters. If it matches, go to the second corresponding characters. If it matches, proceed. Again the fourth is also matching, then fifth is also matching. Now the sixth character doesn't match. So what you will be doing is, you will be moving your pattern one position towards the right, and again continue with the comparison. Now in this case, the second character of the string is matched with the first character of the pattern and it doesn't match. So what you do, you just again move your pattern one position right, and like this you will be doing. And when you move the pattern in such a way that it aligns with the fourth character of this text and with the first character of the pattern, all the characters are matching. So we just declare that a match is found, and we'll increment that n match is equal to 1. Then again we proceed. So again this particular character is not matching, proceed, not matching, then proceed. Now here in this case you can see that this first two characters are matching, but the third character is not matching, but still we just compare with the next position. Okay, so again this is not matching and this is not matching, and then finally when you place here, you get the pattern is getting matched. So we tell that number of matches equal to 2. Now this is a laborious algorithm, and since you have the length of the string is here, it is restricted. What would you do? The length of the string is very long. Then every time you have to place your pattern in the successive positions, and then we need to verify. So which is a laborious task. So we are going to develop an efficient pattern searching algorithm which will minimizes this. So in our pattern searching algorithm, what we do is, we won't do this particular searching, and that is, the idea is we will avoid re-examining the earlier string characters. So this will not be done, this will not be done, and this will not be done, and this will not be done, and again this will not be done, and directly you will get the matching of the pattern the first time, and then this time this particular pattern will be matched and this will be matched, and within 3 steps. Okay, so within this 3 steps this particular pattern could be found in the given text. So we are going to dive into the algorithm or the logic behind this. So the idea is, we are going to create a partial match table. What does this partial match table mean is, we are going to find in the given pattern, is there any sub pattern within the given pattern, is there any sub pattern found or not. and according to that we will build a table which will tell us what action to be performed when a mismatch occurs at a position between the text or the string and the pattern. So let us see how this partial match table is built. Now you just write down the positions of your pattern. It starts with 1 and your given pattern I have taken as ABC, ABC, AC, AB to understand how to develop the match table. What I do is this pattern, okay, this is the pattern what we have. Now what I do is I will align the same pattern at different positions of this pattern and I find whether a match is found or not to find out any sub pattern is there. Sub pattern means any prefixes or suffixes are there. Okay. So now first what I do is we will initialize the value of the match at the position 1 as 0. Okay, we have to initialize that because we cannot align the pattern in the first position, which means everything will get matched. Okay, so that is not required. This doesn't give us any information about the partial match. So we proceed with the aligning of the same pattern in the second position. Okay, second position, and then observe whether any match is there among the characters. Now yes, we just see whether this corresponding character matches. Doesn't match. So doesn't match means at that position you just enter 0. Now next you align the pattern in the next position. Now again compare with the current first character of the pattern with the position of this the next position of this pattern. So here there is no match, so we will just put it as 0. Again go to the next alignment. Now we see that there is a match, so it is matching with this pattern. See, this is the original pattern and this is the displayed pattern, and we are keeping track of the position of the original pattern as well as the displayed pattern. Now the position of the original pattern is 4. The position of the displayed pattern is 1. Okay, so the character present in those positions are compared, and if it is equal then we will set the match as 1. Then we move on to the next successive characters. So the next character in the original pattern is B, next character in the displayed pattern is also B, so we increment that index. Okay, so we have to make it as 2. Next we will compare with the third character. So third character of the pattern matches with the position, that is whatever the position in the original pattern. So again it matches, so increment the index. Move on to the next one. This also matches, so increment the index. Now next it doesn't match. Okay, C and B doesn't match. So that is, now this particular B doesn't match with C, so now the entry should be 0. Okay. Now after making this entry, if the partial match is 0, then what you need to do is the displacement should happen to the position next to it. Okay, so the displacement should come over here, and again start comparing, and the indexing should be reset to 0. Okay, so now when this is compared, I have to set my index from 1. Then next this is compared and it will be B and B. Okay, so just let me show you. B is matching, so it will be set to index 2. Now what is the information we are gaining from this? See, in the fifth position I say 2, the value is 2, which means preceding this pattern there is a prefix of AB. Okay, and in the sixth position I say I have this value as 3, which is telling me in the previous in this pattern there exists a prefix, that is ABC, prior to this. That is the information we get from the partial table. Now having known how to construct the partial table, we will just look at the example what we have seen. So in the previous example, I have showed you this is the pattern, and I need to construct the partial match table as before I have explained. I will be creating the partial match. So imagine, so first one will be 0, and the second here assume A is aligned with B, so it is 0. Then again A will be aligned with C, it will get 0, and then A is aligned with fourth position, so it matches, so you will get 1, and B also matches, it will get 2, and C doesn't match, so you will get D. So again you will be matching with the first position with this, so you will get as 1, and the second position also matches, and third position also matches. So this is the partial match table. Now in our algorithm, we refer this entry as a recover array. Okay, so instead of using the name partial match, we will be using the term recover, where the values are the entries of the array and these are the positions of the array. Okay, so remember this. So this is the first step. So you need to create a partial match table only for the pattern. Now next, so there are general rules for the pattern matching algorithm. If your first character in the pattern and the current string character mismatch, then what you need to do is you have to forward the pattern one position. That is, you have to compare the next character of the string with the first character of the pattern. Just forward the pattern to one position. If the second character in the pattern and the current string character mismatch, which means first character is matching but the second character is not mismatching, it leads to mismatch, then what you need to do is you have to forward the pattern two positions. That is, you need to compare the next character of the string with the first character of the pattern. Otherwise, for any other situation, you have to refer your partial match table to decide where to place your pattern aligned with the text. Okay. Now, let me explain that. So, this is the text what I have shown you in the beginning, and the positions of the text are this one, and we have a pattern and the positions of the pattern are shown. So, which means the length of the pattern is 9, the length of the text is 18. Okay. So, you have to continue scanning till the text, that is the text position is till 18. If it exceeds 18, you have to stop. Now, you have the recover table, okay, which is created in the, as I shown you in the previous slide, we have the recover table. Now what we do is we first take the first character of the text and take the first character of pattern, compare. So both are equal, proceed with the next. Both are equal, next, next, next is also equal, go with the next. Okay. Now we see a mismatch. So what is that we need to do is we have to refer the recover table to find out any prefix is there. Okay. So how do we refer this recover table means you have to find out recover of this position, this pattern position -1 plus 1. Okay. So this is something like a formula you need to use. So this is nothing but recover of 5 plus 1. So what is recover of 5? This is 2. Okay. So 2 plus 1 you get 3. Okay. That means what does this indicate is you have to align your pattern in this mismatch position. So what is the position to be aligned is only 3. Okay. So imagine you are going to move the pattern such that the third position of the pattern gets aligned with the sixth position of the text. Okay. Now in this case both pattern position is 6 and text position is also 6. Okay. So now the idea what this recover table is giving you is you don't go from just aligning with the first. Okay. So you just pick up the third position and align it to the 6th position. Okay, so what I mean is you are going to just place the 3rd position aligned with the 6th position. Okay, and then from here, from this mismatch position, you continue with comparison, because it tells that the prior characters are already examined. Okay, so that is the idea we get from the partial table. So now we will just continue with that. So we have the recover table, and now we are comparing with the mismatch position. Okay, so now after this alignment, we see that both are equal, and then we go with the next one, we go with the next one, we go with the next one, and we see that all successive characters are getting matched. If a match is found, the positions will be incremented, okay, both in the pattern as well as in the text. Now when you increment, it goes to the next position, that would be like the pattern position will be 10. Okay, if it goes beyond the length of the pattern, if the index of the pattern goes beyond the length of the pattern, then we conclude that a match is found. Okay, so what we do is we will increment the match by 1. After incrementing, again what we do is we will refer this recover table to find out how to position the pattern aligning with the text. So now what we do, what is the current position? 10. So apply the formula recover of 10 minus 1 plus 1. So what do you have? Recover of 9 plus 1. So what is recover of 9? 3. So 3 plus 1, 4. So the information which we get is you have to align the 4th position of the pattern with the current position of the text. So current position is 13, and now we need to align the 4th position, which means the prior information ABC is already scanned. Okay, so that is the information we get, and so this is how it will be. So I have aligned the 4th position with the 13th position of the text, and my comparison starts from this mismatch only. Okay, so you will be comparing the successive positions and all are matching, and finally you go out of this range, that is the index of the pattern reaches 10. That means you have to increment your number of match by 2, and also the text index is also exceeding, which indicates we have to stop. That's it. So now we'll see how to build the logic for the partial table. So the input for the partial table building is your pattern. So where m is the length of the pattern means you will be having the characters from 1 to m. Then what is the process you are doing? First you need to use an index variable I and j. Okay, both are pointing to the same pattern. So as I told you, we will be referring this I to refer your original pattern, and j will be referring to the index of the displayed pattern. Okay, so initially I will be 2. Okay, and your j will be 1, because I told you no, the first displacement happens only into the next position. So I will be referring to 2, that is second position, and j will be referring to 1. And then we will be using an array variable to store the partial details. And we will be initializing this recover of 1 is equal to 0, as I have shown before. And then what we are doing is you have to repeat the below steps. So what are the steps? How long it should be repeated? It should be repeated I is less than or equal to m. M is the length of the pattern. So what we are checking? Whether that pattern of I is equal to pattern of j. If it is equal, then what do? You store the j in the recover of j, and then increment I by 1, j by 1. Okay, j will be acting as the index. Otherwise what do? You store j is equal to recover of j, and again you have to reset a pattern to the first position. That is why setting j is equal to 1 and then incrementing I by 1. Okay. So if you do this, you will get the output as your recover table, which will be the same length of your pattern. Now, coming to the pattern searching algorithm. So here the input will be the pattern as well as the text. Pattern will be of length m and text will be of length n. Now in the process, what do? You use two variables I and j to indicate, to point to the elements of the text and the pattern. Now we are comparing the text value with that of the pattern value. So we need to initialize I is equal to 1, j is equal to 1. I is referring to the text position, j is referring to the pattern position. Next, you have to use a variable n match to count the number of times pattern is occurring in the text. So initially n match is equal to 0. Now you need to call this partial match function and get that recover table before proceeding with this pattern searching algorithm. Now you have to repeat these steps as long as your I is less than or equal to, till you reach the end of your text. Okay. So if the pattern of j is equal to text of I, what do? Just increment j by 1 and increment I by 1. That means you are moving to the next positions. If the corresponding character matches, you just move to the next position. How do you move? Just increment I by 1 and increment j by 1. Then what do is, you have to check whether j is greater than m, because we need to check whether the pattern index has exceeded the length. That is what we are checking, and if it is so, just increment n match by 1 and consult your recover table. So how do I consult? You will be finding recover of j minus 1 plus 1. That is your j position. If this j is equal to 1, then you have to move to the next position. So increment I by 1. Else means what? If this corresponding character doesn't match. Doesn't match, what do? You just consult the recovery table. Okay. This algorithm is different from the partial table. Okay. So remember that. So if this pattern, the corresponding character of the pattern and the text doesn't match, then you have to make j is equal to recovery of j minus 1 plus 1, and if j is equal to 1, increment I by 1. So when you complete this process for all the characters in the text, you will get n match, that is your output. Okay. So now I have written the algorithm in the step-by-step process of creating a partial table. So just quickly I will move on. So you will be reading a pattern array of n elements. So it is denoted as PAT 1 to m. Initialize I is equal to 2, j is equal to 1. Initialize recover of 1 is equal to 0. Then you will be repeating these steps as long as you have examined the characters in the pattern. So you will be checking whether this pattern of I is equal to pattern of j. Then if it is yes, you will be setting this recover of I is equal to j. Then increment I by 1, increment j by 1, and again this process will be repeated. Okay, till as long as this I is less than or equal to m. Else, if there is no match, then you will be resetting this recover of I is equal to 0, and you will be setting j is equal to 1, because we need to reset the index to 1. Then you increment I by 1 and go to step 5. So when you complete this, you will get the recover table built, which will be this, the length will be the same as your pattern, and you have to display that recover table. That's all. So this is the algorithm for creation of a partial table. Now we will go to the algorithm for the pattern search, where you will have the inputs as the text as well as the pattern, and you should also have that recover table information. Okay. Now you will be reading the text as well as the pattern. and initialize I is equal to 1, j is equal to 1, n match is equal to 0, and if I is greater than n, you have scanned all the elements in the text, so you can go to the step 14. Otherwise you do this. So what we are doing, we are comparing the text value with that of the pattern value. If both matches, what you do, you just proceed with the next position. So increment I by 1, increment j by 1. Then what do? You will be checking whether j has exceeded m to find out all the pattern values have been checked. If it is yes, then you will be incrementing the n match by 1. Okay, so otherwise you will be repeating these steps. And you have to set, you have to set j is equal to recover of j minus 1 plus 1. That is, if you have found a match, it means that your position of the pattern has exceeded, okay, exceeded the limit. So what we have done is, you have to just recover that position by referring your partial table. That is what we have seen in that example also. And if j is equal to 1, increment I by 1, and again you repeat the process. Now if this pattern doesn't match, it will come to step 12. So where you will refer your recover table, and again if j is equal to 1, increment I by 1 and go to step 4. Okay. So this process will be repeatedly done if I is till I is greater than n. If it is greater than n, you will be coming to step 14 where you need to display your n match. So this is the pattern searching algorithm, which is very efficient than the normal pattern searching algorithm. Thank you for watching. Subscribe and wait for my next video. Thank you.